the difference quotient is something that you use a lot in calculus. It is an algebraic process, and so that's why we teach it a lot during in pre-calculus. But it is something that you use in calculus to help you find instantaneous slope. Okay, it's used in that to help you find derivatives and different things like that. So I've drawn a picture up on the board. It's a picture of a parabola, and it's a picture of a line that is tangent to a point on that parabola. And so that's what's called instantaneous slope. And this right here helps us to find that. So many of you know that I'm taking a calculus class for fun. All of us have different ways of coping. Mine is to just do algebra. So I like to solve math problems. And so, and this has come up. Like I've spent the last week and a half working with the difference quotient. It's called something a little bit different. It's the definition of a derivative, I think is what I was using it. But it's a very algebraic process. And so because it's talking about slope, I wanted to start with something that is linear. So tell me what the slope is of this line. F of x equals negative 2x plus 3. What's the slope of that line? Negative 2. Negative 2. So when I find the instantaneous slope of a point on that line, all of my slopes is going to be negative 2. So when we do the difference quotient for this particular one, we're going to get negative 2. But I want to show you how to do that process. So the first thing that we do in this process is we find f of x plus h. F of x plus h. Okay? So we're going to find f of x plus h. And what that means is I take x plus h and I plug it in for the x in the function that I'm working with, in the negative 2x plus 3. Okay? The next thing that I do is I am going to subtract the original function. Okay? I'm going to subtract my original function. Okay? So I find f of x plus h, then I'm going to subtract my original function. Then I am going to divide everything by h. Okay? The last thing I do, which is always everyone's very favorite thing to do, is simplify. Okay? I'm going to simplify. So we are going to do this process, and I am going to try to use the colors to really show you what's happening. So to find f of x plus h, I am going to plug x plus h in for this x right here. Okay, that's how I do f of x plus h. So I've got negative 2 x plus h plus 3. Okay? Okay, and I'll simplify later, but that's all I've done is I find f of x plus h. Now my next step is to subtract my original. So I have minus my original function, which is negative 2x plus 3. What do you think students sometimes do there? What happens? What do they forget to do? They forget? Yes, that's exactly right. Students forget to distribute the negative. So that's something that we want to be aware of. I think that's where you were headed, Daniel. Okay? Then I'm going to divide by h. I'm going to divide everything by h. Okay? So let's simplify this out and see what happens. First thing I'm going to do is I'm going to do negative 2 times x plus h. So that's negative 2x minus 2h. Okay? Negative 2x minus 2h plus 3. Okay? Now I'm going to distribute my negative. What's negative negative 2? Good. Negative positive 3. Good. Okay, and now I am going to divide everything by h. Okay. What do you notice on the top? What do you notice on the top? I'm going to simplify, so what do you notice? There's several things that will cancel, absolutely. You said the 3's, is that what you said? What else will cancel? Good, so I've got 2x and I've got negative 2x, okay? If you don't have a significant number of things cancel in that step, you've made a mistake, okay? You've made a mistake. So you want things to cancel there. If they don't, go back and see what happened. So now I am left with negative 2h over h. Can h and h cancel? Yes. So my difference quotient to this problem is negative 2. And that makes sense because we're talking about slope. And because this is a line, we know that our slope is negative 2. So the time that this is really helpful is when we are doing something that's nonlinear. We're doing something that's nonlinear. Is it okay if I go off this page? You got what you need? Okay. So here, I need to look at my colors. Red, green, blue, orange. Okay. Red, green, blue. Okay. So we're going to go through those steps again. Okay, and on your test, you will be given the difference quotient formula. And I also won't give you anything more than squared. Okay, sometimes doing the difference quotient on something to the third or fourth is very intense. So I will not give you anything above squared. So the first thing that we're going to do is we are going to find f of x plus h. So I have an x right here and I have an x right here. And I need to plug x plus h into both of those. Okay, so I've got x plus h squared minus 4 times x plus h plus 7. Okay? Okay. The second thing that I'm going to do is I'm going to subtract my original function. So I subtract my original function. And my original function is f of x. So I have x squared minus 4x plus 7. Then I divide by h. Okay. Now, before we start simplifying everything, there's a few things that I need to simplify within f of x plus h and within subtracting f of x. Okay? What do I need to do to that x plus h squared? What do I have to do? Yeah, we've got to FOIL it. Okay, so I have x plus h times x plus h. X times x is x squared. X times h is xh. H times x is hx. H times h is h squared. Now, is xh and hx the same thing? Is 2 times 3 and 3 times 2 the same thing? Yes. So x times h and h times x, they are the same thing. So this actually simplifies to x squared plus 2xh plus h squared. So anytime you do x plus h squared, that's what you're going to get. Every single time. That's what you're going to get. So I wouldn't memorize it, but you should see that pattern every time that you do it. So here is x squared plus 2xh plus h squared. Okay? So I just did this right here is what I just did. Okay? Now I'm doing my negative 4. I'm distributing negative 4x minus 4h Then I've got the plus 7. Okay? Now I want to subtract my original function. So I have minus x squared plus 4x minus 7. I have to distribute that negative. I've got to distribute that negative. Now, by design, what we want to happen is we want everything to cancel out. That's what we want to do. Not everything. We want a lot of stuff to cancel out. Yes, okay, so I've got x squared that can cancel out, x squared and negative x squared. I have a negative 4x and a positive 4x, and a negative 7 and a positive 7. What's left? What is common to everything that's left? H. Okay? Okay. So now I have 2xh plus h squared minus 4h. Okay. Do I have an h in every single term in the top? Yes. So now I'm going to factor that out. So I have h times 2x plus h minus 4. Okay? My h's cancel, so my final answer to this, my final answer is 2x plus h minus 4. That is my final answer right there. Okay? And that's the difference quotient. And what you want to do is you just want to follow the steps. And if you take it piece by piece, it's not terrible. I know it kind of feels terrible, but it's not terrible. Okay? Okay. Is it okay if I move off the screen? Okay. What we're going to start talking about now is we're going to talk about something called, we're going to talk about inverse functions. We're going to talk about inverse functions. And I have done some linear functions up here, and you're welcome to take a picture. I've just used Desmos to graph it. What I have is y equals 4x. That is the red line. That is the red line is y equals 4x, and it is more steep. It's more steep. The blue line could also be written as y equals 1/4 x plus 0. Okay? So I just did x over 4 because that's when we do it algebraically, that's how our inverse comes out. But I want you to realize that that can be written with a slope of 1/4 x so that you can see that. And your blue line is less steep. It's a little flatter. Then my green line is y equals x. That's called the identity. Okay? Y equals x is called the identity. And anytime that you're doing anything with inverse functions, you are going to be reflecting across this line. Okay? And that line is y equals x, anytime that you're doing anything like that. Something is an inverse function when we fold that line, that identity line, and it's reflecting across that. So if you were to fold that, the functions would be on top of each other. So that is that's an inverse function. Now, the key point when you're talking about inverse functions is that your x's and your y's are interchanged. Okay? All of your x's becomes your y's, all your y's become your x's. Okay? Now let's look at this. Let's look at this, okay? Can I move off the screen? Okay. I want you to do -2, -1, 0, 1, and 2. -2, -1, 0, 1, and 2. Okay? I want you to plug that in for y equals 4x. 4 times negative 2. What's 4 times negative 2? Negative 8. Okay. What's 4 times negative 1? 4 times 0. 4 times 1. 4 times 2. Good. Okay. Now, for this one, I want you to plug in negative 8, negative 4, 0, 4, and 8. So you're going to say negative 8 divided by 4, negative 4 divided by 4, 0 divided by 4, 4 divided by 4, and 8 divided by 4. Okay, so you're just plugging it into that second function. Okay? Negative 8 divided by 4. Negative 2. Negative 4 divided by 4. 0 divided by 4. 4 divided by 4. 8 divided by 4. Okay, what do you notice? Okay, they're reversed. Okay, so your x values for your original function become your y values on your inverse function. Okay, that's what's happening when we have inverse functions. Your x and your y values are interchanged. And when we start solving for an inverse function, that's what we're going to be looking at. Your x and your y values are interchanged. So if I look at my original function right here, what is another word that we use often for x values that I put into a function? What's that? What do we call that sometimes? Okay, you're right. We do call it input. We're typically not asked to find the input, but you are correct. What's another one? Domain. Okay? So I want you to look at the domain of my original function. Where does it show up in my inverse function? The range. Good. Okay? The range. So that is an important thing that you need to know. The domain of original function is the range of the inverse function. Okay, and that's going to be important as we start working on those. Here we have the domain in the inverse. What's the domain of the inverse to the original? Good. Very good. Okay, so the domain of the inverse is the range of the original. Okay? Okay. Now, if you are given two functions, the way that you can determine if they're inverses of each other is by using composition of functions. Okay? That's how you can determine if they are inverses of each other. So we're going to do composition of functions again. Okay. So we're going to do fog and we're going to do goth. And what that means is f composed of g of x and g composed of f of x. If two functions are inverses, when I do their composition of function, and it doesn't matter if I do f composed of g or if I do g composed of f, when I simplify everything out, I'm going to get x if they are inverse functions. Okay? So what I have to do is on the first one, I am going to take g and I am going to plug it in for that x right there, because I am doing f composed of G. I'm doing F composed of G. Okay? So I'm going to plug that into it first. So my F my F is 5 over this function, 5 over x plus 2. Okay? That's what I've plugged in right there. So when I simplify this, my 2 and my negative 2 cancel out. Okay? I'm left with 5 over x. Another way to write that is 5 over 1 divided by 5 over x. That's another way to write it. When I am dividing fractions, I do 5 over 1 times the inverse. And what happens right there? What am I left with? I'm left with x. Okay? I'm left with x. So it works. So that means these two are composition. They are inverses. Yes, they are inverses. Now, it doesn't matter which way we go. Okay? So now I can do Goff. I can do G composed of F. So what this means is I am taking this right here and I am plugging it in for this x right here. Okay? That's what I'm doing. So I have five over and this is a complex fraction. Okay? So I have 5 over x minus 2 plus 2. Now I'm going to ignore that plus 2 for a second, and I'm going to show you what happens. This is just dividing fractions. That's all we're doing. So I have 5 over 1. What operation is this right here? Is it division? Then I am dividing 5 over x minus 2. So that is 5 over 1 times x minus 2 over 5. What am I left with? X minus 2. X minus 2. Okay? So now what I have is x minus 2 plus 2. And do I get x? Yes. So it means these two functions are inverses of each other. So if we graphed them and we looked at them, it's going to have all the characteristics of inverse functions. Okay? Now, the way we determine if something has an inverse is we have something called the horizontal line test. Now, remind me what the vertical line test told us. What did the vertical line test tell us? Whether or not it is a function. That's what the vertical line test tells us. Now, most of what we deal with in this class, we deal with functions. Okay? Pre-calculus is almost always, we're dealing with functions. So this particular function right here, it does pass the vertical line test. Okay? If I drag it across, it's not touching any point more than once anywhere on the graph. Okay? But it does not pass the horizontal line test. So the horizontal line test is when we pull a horizontal line down to see if it touches at more than one point at once. So that is called a one-to-one function. The vertical line test tells us if something is a function. The horizontal line test tells us if its inverse is a function. Okay? This does not pass the horizontal line test. So what that means is this is not a one-to-one function. And it means its inverse is not a function. Now, if you wanted to find the inverse of x to the fourth plus 3x third minus 2x squared minus 2, you could find the inverse, and we could graph the inverse, and we could look at the inverse. What you need to understand is that inverse is not a function. We can still do the inverse, but the inverse would not be a function. So this is not a one-to-one function. So with a function, our x's are not allowed to repeat. In a one-to-one function, your y's are not allowed to repeat either. And in this right here, we have several y's that repeat. We have infinitely many y's that repeat, actually. Okay, and so that's what makes it not a one-to-one, because my y's are repeating. Now, the trick to this is definitely the algebra. So we're going to kind of look at some graphs of functions. Actually, before we do this, is this a one-to-one function? It's not. Why?
Because it's obviously got more than one y.
Good. Good. It doesn't pass that vertical line test. If I pulled a vertical, it does pass the vertical line test because it is a function. It does not pass the horizontal line test, so it's not a one-to-one function. It's still a function, and there's all sorts of stuff we can do with it. It's just not a one-to-one function. Okay? Now, I know there we go. Okay, this is what I want to look at next. And this is definitely worth taking a picture. You can either take it now or you can take it after I write all over it. These two functions are inverses of each other. Okay? We've got y equals x to the third minus 4, and then we have y equals the cubed root of x plus 4. Okay? So there's a couple things that I want you to look at. I want you to look at the red graph. The red graph is my original function. Okay? The red graph is my original function. Where does the red graph cross the y-axis? Good, at -4. Okay? So this is 0, -4, and that is my original function's y-intercept. Okay? Tell me what's happening right here. What is that? The x-intercept okay, and it is -4, 0. So when you have inverse functions, your y-intercept becomes the x-intercept and vice versa. Okay? So your y-intercepts become your x-intercepts become your y-intercepts. That is also true for domain and range. It's also true for domain and range. The domain of my original function is the range of my inverse. Now, this is not linear, but if I were to fold these two on top of each other, would they show up? Would they be right on top of each other? Yes, okay, that's an inverse function. You can see that identity line right there, y equals x. Where do the two functions cross? Where do the two functions cross? Where does the blue and the red cross? Good. And what line is it on? Good. Good. Okay, your functions will always cross on identity line. Okay, sometimes the two functions will cross in more than one spot. Sometimes the functions will cross in more than one spot. Okay. When I am talking about x to the third, if I plug a negative number in for x, okay, if I plug a negative number in for x, like negative 2, what is negative 2 to the third power? You went one too far. That's negative. That's
negative 8.
It's negative 8, okay? Negative 8. If I plug negative 1 in to x to the third, what do I get? Negative 1, okay? What if I plug negative 3 in? What do I get? Negative 27. Good. Okay? So when I plug a negative number into something being raised to the third power, I get a negative number. Okay? So I can take the cubed root of negative numbers. And that's what you need to understand right here. Do you see how my radical, you know it as a square root symbol, has a little 3 right there? Okay? That means I'm taking the cubed root of this. I'm taking the cubed root of x plus 4. Okay? And because of this, it's okay to have negative numbers inside. Now, if that was a square root, it wouldn't be okay. But a cubed root is okay because it's odd. It's an odd root. So, if I ask you, what is the domain of x to the third minus 4? Now, you can look at the graph. But for x to the third minus 4, I'm not in a fraction or a rational, and I don't have a square root. So what's the domain of that function? Do I have to limit it in any way? No. Okay, so what's the domain? You got it. Negative infinity to positive infinity. Okay? So the domain of my original function right there is negative infinity to positive infinity. Okay? So if the domain of my original function is negative infinity to positive infinity, where can I put that on the inverse function? Range. Perfect. Okay? So negative infinity to positive infinity. Now, look at the graph of the cubed root of x plus 4. Looking at the graph, does it go all the way to positive infinity? Does it go all the way to negative infinity? So what's my domain there? What's my domain? What kind of numbers can I plug in for x? Anything. Anything. Okay? So my domain here is also negative infinity to positive infinity. And it's because this number right here is odd. Okay, if that number was even, like square root or the fourth root, you couldn't have negative numbers in there. But because it's odd, you can. So my domain for my inverse is negative infinity to infinity. That means my range of my original. Okay? Now, the tricky part is finding the inverse. Okay, so we're actually doing this a little bit backwards because we've already talked about the graph. So you can see what the graph looks like. Okay, so there's our graph. We want to go from x to the third minus 4. That's our original function. We want to go from x to the third minus 4. We want to find our inverse function. We want to find our inverse function. And this, we have some steps. Okay, so the first thing that we're going to do is we are going to replace f of x with y. That's what we're going to do first. I'm going to take out that f of x and I'm going to put in a y. So instead of f of x equals x to the third minus 4, I'm going to have y equals x to the third minus 4. Okay? My second step is going to switch x and y. Okay? I am going to switch my x and my y. So instead of y equals, I'm going to have x equals. Instead of x to the third, I'm going to have y to the third. So I have switched x and y. And then my third step is to solve for y. And step 3 is where the challenge comes in because you're doing a lot of stuff algebraically. And sometimes that can be a challenge. Okay? So the first thing I'm going to do is add 4 to both sides. So I get x plus 4 equals y to the third. Okay? How do I get rid of the third? I've got y to the third. What's the inverse of y to the third? Cubed. Excellent. So I am going to take the cube of both sides. Okay? So I'm taking the cube. And don't forget that 3. Because if you forget that 3, what is it? Square root. Good. So I have the cubed root of x plus 4 equals y. Okay? The blue is the hard part. The blue is the hard part. Okay? My fourth step, replace y with f inverse of x. That's the notation for inverse, is that f to the negative first power. So our inverse here is f to the negative 1 of x equals cubed root of x plus 4. And that's what we had. That's what we had on our graph. That's what we had there. Okay? So now we're going to do one that's a little bit more intense algebra. Okay? And we're going to have to limit our domain. Is it okay if I show you the graph? Okay. That's not it. There it is. This is a graph. Okay? So this is the one that we're going to work on. Red is my original function. So you can see my red here. Blue is the inverse. Blue is the inverse of that function, and green is my identity line. Notice where my functions cross. Okay, in this situation, they cross twice, but both of them are on that identity line. So they do cross twice, but they're on that identity line. We are going to have to limit our domain. We're going to have some asymptotes here to where our graphs can't cross because we've got stuff in the denominator. And the algebra is going to be a little bit icky. It's going to be a little intense. And so that's why I want us to go through it. So this is where we're going. This is where we're going. Okay, are we ready? Okay. So I am finding the inverse. This is my original problem. Okay? First thing I'm going to do, replace f of x with y. Okay? So I'm going to have y equals 5 minus x over 3x plus 2. That's my first step. Okay? My second step is to switch x and y. Okay? Now, do you see how I have two x's right there? See how I have two x's right there? you're putting y in for both of those. Okay, so anywhere there's an x, you're putting a y. Anywhere there's a y, you put an x. Okay? So I'm going to have x equals 5 minus y over 3y plus 2. Okay, now this is where the algebra comes into play. Now we are going to solve for y. Okay? If I had the equation x over 3 equals 12. X over 3 equals 12. What operation is happening between the x and the 3? Division. How do I undo division? Multiplication. So what would I do to solve this equation, 12 equals x over 3? Multiply both sides by 3. That's exactly what I would do. What happens to the 3's on the right-hand side? They cancel. And what am I left with over there? X. Okay, so I'm going to say that a slightly different way. When I multiply both sides by the denominator, on the right-hand side, that denominator cancels because I'm multiplying both sides by that denominator. Okay? Then on the left-hand side, I just multiply it out. So, our first step in solving for y is going to be to multiply by this denominator. And students usually do okay with multiplying by the denominator, but they forget that it cancels out. When I multiply that, I am undoing the division. And so that denominator cancels out with what I'm multiplying by. So I am left with 3y plus 2 times x equals 5 minus y. That's what I'm left with. Now, what do you think I should do on the left-hand side? Distribute. Absolutely. We're going to go ahead and distribute. 3y times x is 3yx. You can write it 3xy. You're good either way. And then x times 2. Okay. This is the part where students want to stop. Okay? This is the part where they want to stop. Okay? They see that they've got this 5 minus y on the right-hand side, and they're like, oh, I just subtract 5 from both sides and divide by negative 1. That's all I've got to do. Yes? Yes, thank you. Thank you very much. Whoops. There we go. There we go. No, that's not the right place either. How about here? Is that the right place? Thank you. Okay. So what happens is they see that y over there and they want to get that y by itself. So they subtract 5 from both sides and then they want to divide by negative 1. What is the problem with that plan? We don't need to divide by 5. What do you have on the left-hand side? A y. Okay? So I can't divide anything or isolate anything until I get those y's on the same side. So what I'm going to do now is I'm going to add y to both sides just so I can have the y's on the same side. Could I get rid of this at the same time too? How would I get rid of this? How do I move this? How about I say it this way? How do I move this to the other side? Subtract 2x. Yeah, subtract 2x. Okay? So I am going to add y to both sides, and I'm going to subtract 2x from both sides. And I'm doing that in the same step because this is pre-calculus, and we're capable of that. Okay? Are 3yx and 1y like terms? They're not like terms. They are not. So I have to write this as 3yx plus y And then I'm left with 5 minus 2x. When you get here, you are typically okay. Students are usually okay, I got this at this point. What do I need to do with that y? What can I do to get those two y's as one y?
Divide the 3yx by 3x.
Okay.
And
Okay.
add the y's together.
Okay. I don't want to do that because then if x is 0, it gets a little messy. Yes. Okay. You can factor out the y. That's what we're going to do. We're going to factor out the y. So I have y equals 3x plus what? 1. Yes, good job, good job. We are there. Okay, now what do I divide by? I can divide by a binomial. So I divide everything by 3x plus 1. And we have done it. So 5 minus 2x over 3x plus 1. Okay, I've got one more step. But you know what? It's nothing compared to what we just did. What's my last step?
Replace y with
Excellent. Replace y with f inverse of x. So then I have f inverse of x equals 5 minus 2x over 3x plus 1. Let me write that up here because it's on top of the words. F inverse of x equals 5 minus 2x over 3x plus 1. Okay, so this is my inverse right here. This is my inverse. Okay, we know what the graph looks like. We know what the graph looks like. Okay, now we need to find our domain and our range. So here it is. So I want to start with my red. Good luck at your track meet. Okay, I'm going to start with my red. What's in the denominator? What's in the denominator of my red graph? 3x plus 2. And what can that not equal? 0. Okay? So I get 3x cannot equal negative 2. Divide by 3. X cannot be negative 2/3. Okay? Now, for my blue, what can't be 0? What cannot be 0? Good. 3x plus 1 cannot be 0. So 3x cannot be negative 1. I divide by 3. X cannot be negative 1. Now, we're going to write this in interval notation, and we've got it. We're good. Okay? I still see a couple people writing, so I'm just hanging tight for just a minute. Okay? So, here, my domain, I forgot what, negative 2/3. Okay, so x cannot be negative 2/3. Okay, can it be anything else? Is it okay if it's anything else? Yes. So my domain of my original function is negative infinity to negative 2/3 union negative 2/3 to infinity. Okay? Now, that's my original function. So where do I put that on my inverse? Range. Good. So I have negative infinity to negative 2/3. Union negative 2/3 to infinity. Okay. For our inverse function, was it negative 1/3? Is that what it was? Negative 1/3? Okay. X cannot be negative 1/3. So to write that here, it's negative infinity, negative 1/3, negative 1/3 to infinity. And our domain of our inverse is our range of our original. Okay?